minus y
s minus y divided by x log y by x minus 2x.
Yeah. Okay. Now it's a homogeneous differential equation. If you will check, you will find it. So the next step will be taking the substitution y is equals to.
Lambda y.
Okay. Or you want to check is it a homogeneous or not?
Oh no, it's okay. Y is equal to vx.
Then dy dx is equals to
v plus x dy by dx, dv by dx.
now we will substitute it over here.
So minus vx divided by x log vx by x minus 2x.
So we will be having minus vx by x
Minus
log
vx
v
by yes.
minus 2. Now that we from the other side we can take it to bring it to this side, right?
Yes.
Right? Okay, let's take the LCM. Let's try simplifying it. What are we going to have? The LCM
Okay.
will be
Yeah, but the LCM will be x log v minus 2.
and here we'll be having minus vx minus v and in bracket
X log v minus 2.
let's open the bracket. Is there any term which will cancel out? Is there? Let's check it. So minus vx minus vx log v plus 2xv, right? Or 2vx,
Yes.
right?
Yes, ma'am.
By x log v minus 2x. This 2xv and this vx, it's the same like terms we are having, right?
Yes, ma'am.
So it will be just tell me
Minus v x log v plus 2.
I'm saying that this 2xv and vx, these two are like term. xv and vx is the same thing. 2vx
So we
minus
cancel
vx.
them. We cancel vx, xv and vx.
We cannot cancel.
Oh,
Take a pause and tell me. Two vx minus vx will be 2y minus y will be we can do the subtraction. That's what I'm trying to say over here. That can you see that we can
okay.
do the subtraction?
So it's just vx?
Exactly, it's just vx. Getting it?
Yes, ma'am.
Minus vx log v. Any confusion so far, Murtaza?
No, ma'am.
Over x log v minus 2x.
We can subtract vx and vx.
Yeah, we can subtract Vx and Vx. Which Vx? Now we are going to subtract which Vx, Murtaza? Now you are saying that we can subtract? No, this
Okay.
is Vx and this is Vx log V. These two
Okay.
are completely different. Okay, yeah, we can
Okay.
take out Vx common, but we cannot subtract Vx. Okay, if you are having x minus x log 2, is it possible for you to subtract x and x?
No.
Never ever we will do that. So x dv dx is equals to, let's see, are we going to get something which is like integrable easily? So x, we will take out common from the numerator and denominator and we will cancel them, right?
Yes, ma'am.
So what are we left with?
We take
E,
Vx common. Yeah. And then we take x common in the denominator. And the x's will get cancelled.
okay, Vx you want 1 minus log v x common log v minus 2 xx common xx common. Now we
Yes,
will
ma'am.
keep v on one side and we will keep x on the other side. So here we will be having log v minus 2, right?
Yes, ma'am.
This dv is equals to dx by x over v is there and
1 minus
1
log.
minus log v is still there. Now let's see whether how can we do the integration over here. This is the main thing. If we can do easily integration, then yeah, we are done with the solution. Be it general solution, be it particular solution. So the denominators part, if we will substitute the denominators part, are we going to get the numerator? Let's check it. Just a moment, let me go through the previous steps so that I can check whether the simplification we have done correctly over here. You just check the question. Have you said to me the correct, like everything match it? Is there any difference with the question which you are having in this question? I'm checking the other steps and then we will be thinking about the integration. Okay?
Okay.
Question is correct, right, Murtaza?
Uh,
Shall I scroll down? Have you matched the question?
yes, ma'am, it's correct. Ma'am, for this type of questions, how much marks will we get until the variable separable?
Yeah,
Just before integration.
just before integration, this much if you will do. And if the question is carrying 4 to 5 marks, obviously it will carry because still we have to find the solution and still. So yeah, easily we will be getting 3 marks.
Okay.
Okay. So yeah, I can see all the steps are correct. We have not done any mistake. Yeah. Minus v x log v minus 2x minus vx log v plus 2xv. 2xv minus vx is only vx minus vx log v and the denominator is as it is. Yeah. X we have taken out common and we are having this integration. Now we just have to think about the integration part. So let's see what can be done over here. Can we make the numerator also 1 minus log v so that like for at least one term it will get cancelled out? Okay, so let's check it. This log log v minus 2. Can we write it as a minus common I am taking from the numerators part. So it for now it became 2 minus log v, right?
Yes, ma'am.
Right, Murtaza?
Yes, ma'am.
Let's focus on this part only. So minus common, this 2 can be written as 1 plus 1 minus log v. Can we write it like this? Can you? And
Yes, ma'am, we can.
okay, 1 minus log v in the denominator dv. Let's see whether like what else can we do over here. So the first integration is coming out like this, 1 by v, 1 minus log v, right?
Yes.
Right? And the second integration plus sign is coming out. This integration actually is not that tough. Can you see? The second integration is 1 minus log v over v into 1 minus log v. Can you see it, Murtaza?
Yes, ma'am.
Now are you able to understand? Oh, okay. In front we have taken minus sign common, so we have to maintain that. Okay, that side also minus sign is there. Okay. Now, if you will focus on this part, can we do the substitution that 1 minus log v is equals to t? Okay, then 1 is 0. Log v is 1 by v, right? dv is equals to dt. Yes or no?
Yes, ma'am.
And dv by v we want over here. Can you see v1 by v dv is already there. So 1 by v dv is already there. It will be is equals to minus dt. So actually you will be able to do the integration also by yourself. Can you see?
Yes, ma'am.
At first it seemed like it is not that simple. But when you will keep on doing it, definitely you will get it. So minus dt over 1 minus log v I have taken as a t, and automatically this v is getting absorbed. The dt by t I am getting for the first integration, and second integration is nothing but just this 1 by v dv, which we know it is just log v. Okay, this is what we are getting. Other side, this is
Yes, ma'am.
still there. Can you see it became so simple? So minus, we just have to be careful with the sign. Patiently you should do. Log t, t means what? T means 1 minus v. So I am
1 minus.
writing 1 minus v. Okay. T means 1 minus log v. Okay. T means 1 minus log v. Not only v. 1 minus log v. And 1 by v means just log v. Other side also we are going to get log only,
Log
right?
x. Yes, ma'am.
Log x plus log c, let's take. So that all the
Okay.
log we can just cancel them out. Okay.
Okay.
So it will be, let's open the bracket. It will be plus log 1 minus v plus, not plus, minus log v. Yes or no? Yes or no, Murtaza?
Yes, ma'am.
I said to you, if you don't do any calculation, at least when you see log on both sides, try applying the property of logarithm. So here, can we apply that log of
Log a
1
by
minus
b.
b
Yes, ma'am.
is equals to log x plus log c.
Yes,
Okay,
ma'am.
log x also we are going to pull, let's just take in this side. So we will be
Minus
having
log.
log 1 minus b by b minus log x, exactly. And that side, let's keep log c. Now this again will go in the denominator, that log of m by n. M is now this, by n is this. Right, Murtaza? Is equals to log c.
Yes, ma'am.
Can you tell me what are we going to get from the bracket part? where this x will go with the numerators part or with the denominators part? Let me know. X will go with 1 minus v or x will go with v.
X will go with V.
X will go with v, exactly. So 1 minus v by vx is equals to, let's see. We can write 1 minus v by vx is equals to c. Okay.
Okay.
Is it clear? Now v value we just need to put over here. If any like more simplification is possible, we can do over here. Are you getting it, Murtaza?
Yes, ma'am. Got it.
So this is how we will do it. Now x we can take LCM and we can just cancel x and x. So it will be x minus y.
Ma'am, how is it V into Y by X?
Sorry, I must into x. V is y by x and x is just x, right?
Yes, ma'am.
So this will be just a little bit more simplification we can do over here. So we can write the numerators part x minus y, right? By x, and this x and x will go by y, right?
Yes, ma'am.
That means x minus y by xy we can write is equals to c. Here we can move on.
This is
Getting
the
it?
required general solution.
Yeah, this is the required general solution.
Okay, ma'am.
Okay. So yeah, at first it may look like that log is there, how we will proceed, what we will do with the log, but eventually you will find that when you will just keep on doing this, that's all about calculus. You have to solve it. You have to solve it, and then there comes a time when you will feel that okay, this is you already know, you have already done such integration in the integration chapter. Okay.
Okay, ma'am.
Okay, Murtaza. Next,
We can continue.
we can continue. The
Yes,
next topic or homogeneous is complete. Like all questions you have practiced, right?
yes, ma'am.
Just let me take the next one. Now there comes the concept of linear differential equation. Okay, and the pattern of linear differential equation will always be like this. Here we will find the integrating factor, and here we will solve this type of differential equation which will be having this pattern. We will find the integrating factor and then we will simplify it. So let's start solving the question. Okay, since we have also limited time, so better to solve the question and try to understand the concept with the help of question itself.
Okay, ma'am. Is this the last topic of the lesson?
Yeah, in your NCRT, is it the last one?
Yes, ma'am.
Yes. So this is the last one. Once you will understand this concept. That means you are done with the whole calculus, right?
Yes, ma'am.
Yeah. So suppose we are having dy by dx is equals to, okay, one more thing, let me notify over here only. Whenever we are having this type of structure, then we will be finding the integrating factor at first. Integrating factor we will be finding, that is e to the power
Power PDA.
t dx. Okay. So let's solve this question. Dy by dx is equals to minus y is equals to cos x. So the format is, at first I said this is the linear differential equation. The format, if the format is like this, dy by dx plus p y is equals to q, where p and q are, you can say p and q are constant functions. Okay, p and q are constant function, like such a term which will be having x along with itself. That's called p, that's called q. Okay.
Okay, ma'am.
So at first here we will be finding the integrating factor. Can you tell me what is the integrating factor? E to the power. What is p? What is q? First tell me from here. What is p? P is
P
what?
is minus y, Q is cos x.
Is it minus y or minus 1?
Minus
Minus 1. And q is cos x.
cos x.
Okay? Yeah. Now we will be finding integrating factor by taking p dx, right?
Yes, ma'am.
That means it will be e to the power
Minus y.
minus dx
Yes, ma'am.
minus cos you say.
No, ma'am. Minus 1, I say.
Yeah, minus 1. So e to the power, what will be after doing integration, what are we going to get as an integrating factor?
Minus x.
Yes, e to the power minus x we will be getting. Now this integrating factor, we have to multiply in this differential, the given differential equation. That is one of the way. Or other ways you can also find the solution directly. Let me check which like method will be easier to you. One of the method I am showing you, that we can multiply the integrating factor with the with like both sides we will be multiplying the integrating factor, and we will end up having this one. Dy dx e to the power minus x minus e to the power minus x y is equals to e to the power minus x cos x. And if you will focus on the left hand side part, you will find that it is nothing but d dx of, let me write it, d dx of y into e to the power x. Check it. First function, first the derivative, like derivative of first and one of the function, plus if you will do this one, no, e to the power minus x into y, rather y into my e to the power minus x, let me write it this way. So then only it will make sense to you and you will be able to relate with the previous step. E to the power minus x into y. Check it. First function, uv rule if you will apply, so you will keep, what you will do, if suppose e to the power minus x is u and this is v, so you v dash, right? Or u
Yes, ma'am.
dy
Dy
dx.
by dx.
Yeah, u is e to the power minus x plus v v,
Plus, yeah.
and derivative of e to the power x minus x will be minus e
Minus
to the
e
power
to.
minus x. Can you see this? This is what we are
Yes,
having
ma'am.
over here. So basically, we have to multiply the integrating factor, whatever we have got on both the sides. And then we will, this is the like explained way, that this is how we have to proceed, and we will end up having this. And on the other side, still we are having just e to the power minus x into cos x. But in few curriculum or few book also, it is recommended that directly also we can write. Directly we can write. Have you seen someone writing it directly? The integrating factor, just multiplying on the other side with q and writing the solution directly?
No, ma'am.
No? Okay, let's do the multiplication only, because both are same thing. Both are exactly the same thing. So this is what we are having. If we will integrate both side now, now we have to integrate both sides. Okay, if this side we will integrate and this side along with dx we will integrate, this side we will integrate, here we will end up having the same thing, nothing else. Okay, and here we have to think about doing the integration. That way we will be able to get the solution. That means y is equals to whatever. Getting it, Murtaza?
Yes, ma'am.
Okay. So what I am talking about, that you can also write directly that y into your integrating factor. You can also write directly that y into your integrating factor is equals to integration of q into your integrating factor dx. This is also directly you can write after finding the integrating factor. But from where exactly it came from this part. So better you do this much and you do step by step. Don't skip the steps. Okay. So we will be having, let's focus on finding the integration of e to the power minus x into cos x. Can you tell me how to do this?
We apply chain rule, so minus e
Chain
to the
rule
power
or
minus x.
integration by parts?
Oh yes, ma'am. Sorry.
By parts we will apply, and it is just loop we will getting, like one time we'll do, one more time we'll do, we will end up getting the same, right?
Yes, ma'am.
Let's do it separately. Do it, Murtaza. Do the integration of e to the power minus x cos x dx. What are we going to have? First function, integration of second function, minus integration sign, then derivative of first function, right?
Yes, ma'am.
Do it and let me know what exactly are you getting the final step. Do it directly, Murtaza. Okay? Because yeah, it is acceptable in board also. Directly you will be able to do. I'm not talking about this part, I'm talking about the previous part. Once you got the integrating factor, let me explain over here. Once you got the integrating factor, what you will do?
Yes, ma'am.
Let just a second. Let me explain it. Solution of the given differential equation will be y into integrating factor, okay, is equals to integration of q
Q
into
into IF.
integrating factor plus c. Write this step every time directly. I
Okay,
was
sir.
showing from where exactly it came. It came from that part only. We are finding the integrating factor and we are multiplying it in our original differential equation. On both sides we are doing the multiplication and then we are getting this step, the rectangular box step. But please write it directly every time. Okay?
Okay, ma'am.
Okay, you will be getting full marks for that. So yeah, still you have to find the integration of this. You must have taken which one you have taken the first function, which one you have taken the second function.
I took e to the power minus x as the first.
Okay, we can take it. Okay, I said to you that whenever we are having e to the power x and cos x, like whatever way you are taking, eventually the same step we have to follow. So we will be having first function, integration of second function, integration of cos x will be sin x, right? Right?
Yes, ma'am.
Plus sin x or minus sin x?
Minus sin x. It, no,
Derivative,
it's plus sin x, plus sin x.
exactly. Minus derivative of first function. So d dx of e to the power minus x, it will be to the minus e to the power minus. Then integration of cos x, it will be sin x. Okay, directly I am writing the steps. Any confusion so far?
No, ma'am.
Plus e to the power x minus x sin x dx. Now, we will be focusing on this integration. Okay, so e to the power minus x sin x plus this integration, again we will apply by parts. So first function, integration of second. Now this time sin x integration will be
Minus cos x.
then minus sign is there and then derivative of the first function, and this one's minus. Okay, both minus sign will neutralize each other. I can see it, right?
Yes, ma'am.
Here we are having, still we are having I, so e to the power minus x sin x plus, not plus, minus e to the power minus x cos x. Minus, this minus minus sign in the bracket is neutralizing each other, so we are having just I later, right? And it became 2i is equals to this. Any confusion, Murtaza?
No, ma'am.
E to the power minus x also became 2. And this I we can substitute over there. Here, 1 by 2 e to the power minus x is there, sin x minus cos x is there, right? So cos x minus sin x, sin x minus cos x plus c. Okay, we must write c over here directly, the constant of integration. And yeah, this is what we are getting. Any confusion, Murtaza? Now this, you have to keep y separately on one side, and whatever extra is there e to the power minus x, you can shift to this side, and that way you can keep your answer. So we can keep our answer like this: e to the power minus x, we will shift to this side. So it will go in the denominator of the first part and the second part. In the first part, it will get cancelled out. So we will just be having 1 by 2 sin x minus cos x. And the other part, it will go in the denominator, that is c by e to the power minus x. We can write it as a c e to the power x. Yes or no?
Yes, ma'am.
And this is our solution of the given differential equation. Clear?
Yes, ma'am.
Let's do the next one. Let's solve this one. let's the linear differential equation which I have written at first, dy dx plus py is equals to q. Does it looks like that? Dy dx plus py, does it looks like that? Dy dx plus py is equals to q? Yes or no?
Yes, ma'am.
Any extra term is there?
X is etc.
X is extra, so we need to divide both side by x in our given question to make it like this. Getting it?
Yes, ma'am.
We will be having dy dx, and this will be plus 2y is there. It will be plus 2y by x is equals to x square by x is there. Okay, so we will be having dy dx plus 2y by x will remain as it is, and here we'll be having only x. Yes or no?
Yes, ma'am.
Please do find the integrating factor, no? What are we going to have here, Murtaza? 2 by x dx, yes or no?
Yes, ma'am.
2 by x dx will be e to the power 2, and this 1 by x dx is what? Integration of 1 by x dx is
Log X.
log x to log x. Now every day I'm writing the properties. Have you learned the property of logarithm, that this front part can go in the power of x? Do you know that?
Yes, ma'am.
Now e to the power log e is nothing but just 1. Okay, so x square is the integrating factor over here. Basically, e to the power log of f of x. Here we understand that base is e. E log e, that is only becoming 1. We will end up having the result as this only, the function which we are having. That's why we can have just x square over here, and that is the integrating factor over here. Getting me?
Yes, ma'am.
Now, this is our original differential equation now. This is our original. Don't see the first one. First one was the question. We did the customization. This is the linear differential equation we are having. So now the solution, when we will write y into integrating factor is equals to integration of q into integrating factor dx plus c. This is how we will write the solution directly. Right, Murtaza?
Yes, ma'am.
So y into integrating factor is x square over here. Okay. Q is you can see here q is x. Okay. Instead of this one, we must say this one. Q is just x. Can you see it, Murtaza?
Yes, ma'am.
And this is very simple. You will be able to continue from here, right?
Yes, ma'am. I can.
What integration we have to do here? Can you tell me once so that I can leave it? If we will focus on the rectangular box, what integration we have to do over there? Integration of,
Or can't we multiply X to make it X cube?
yes, that's why I'm leaving it for you. Can't we? We must do that. Okay, that's why I'm saying
Yes,
that
ma'am.
now it is very simple. Yes or no?
Yes, ma'am.
Okay, every time we will be doing that. So now it became very simple. X cube, x to the power n rule we can apply, and I am leaving this now. You will be able to proceed, right?
Yes, ma'am.
Let's do the next one. If suppose we are having y dx minus x plus 2y square dy is equals to 0. Now it doesn't look like. that format where we were having dy dx plus p into y is equals to q. This format it doesn't look like. So maybe we will think that this is the variable separable where we will be able to separate them. Let's check it. We will think if the question will come in the exam, then how we will understand that it is from the linear differential equation part. How we will understand? We will not be able to understand. So let's try using the approach which we have learned already. Let's see whether that is working over here or not. So if you will apply that, y dx is equals to x plus 2y square dy, and hence dy by dx is equals to y by x plus 2y square, right?
Yes, ma'am.
Or maybe if you are not writing dy by dx, maybe at this point only, at this step only, if you are trying to keep y on one side with dy and x on another side with dx, that is also not possible over here, right, Murtaza?
Yes, ma'am.
Now we will try checking whether it is homogeneous or not. So we will take, at the place of y we will be taking lambda y, at the place of x we will be taking lambda x, at the place of y we will be taking lambda y, that's whole square. Okay, to we are just checking it quickly. Is it homogeneous? Then we can take the substitution y is equals to vx, right?
Yes, ma'am.
So
So
if we will check like that, we will be getting lambda y in the numerator, lambda x over here, and 2 lambda is square y square. Can you see it is not possible to take out lambda common from the denominator? For homogeneous differential equation, we were able to take out lambda common from the numerator, lambda common from the
yes, ma'am.
denominator. Here we don't, like, it is not at all possible. It is not homogeneous. I said to you there you will be able to take out lambda common from the numerator, maybe lambda to the power 4 from the numerator and lambda square from the denominator, and you will end up having lambda square remaining. In your syllabus you have always seen that lambda and lambda is getting cancelled, but there exists such question where lambda will not get, like, lambda will not cancel out each other, and that is also homogeneous, but that time we will be able to keep lambda separately the way I'm trying to show over here. Can you see?
Yes, ma'am.
Okay, this is also homogeneous. So either we will be able to remove lambda, or maybe lambda totally we will be able to keep it aside, and we will end up having the original differential, our original function we will end up having. From where we have started, that only will come back with maybe lambda to the power 2, with maybe lambda to the power 3. That is homogeneous. With maybe lambda to the power 0. That is homogeneous. Okay.
Okay, ma'am.
And if it is not homogeneous, then y we will solve it by taking the substitution of homogeneous. Y is equals to vx is not working, and only three exercises are there. That is variable separable, homogeneous, and linear. If it is not variable separable, if it is not homogeneous, then let's check it this way also. Getting it, Murtaza?
Yes, ma'am.
So in exam, it will not be written. That's why most of the students get confused, because they practice exercise wise. That okay, this question is from this exercise. If every question, each and every question we have to solve like this. And that's why we say start solving the question paper. There it will not be written that this question belong to which exercise. So if nothing is working over there, then last hope is this linear differential equation. We will try arranging it like this. So if we will try arranging it like this, then dy dx we have kept already on one side. We will be having dy by dx is equals to what are we going to have? Y by x plus 2y square, right?
Yes, ma'am.
Okay. Now dy by dx plus, is it possible to write it in terms of y? Is it? Is it possible, Murtaza, to write it in this manner? Dy dx plus py is equals to q. if we will take it in this side, then we will be having minus y by x plus 2y square. And the other side we can take as a 0, but it's py we are not getting. Q can be 0 also, can be, okay, or maybe the function of x, but here still we are not able to make, so we will think about the approach which may help us. First, let me check whether I have written the question correctly, whether 2y square is there or not, then only we can think about it. Yeah, it is 2y square. Okay, so now we have to think about the trick which we can apply over here. So if we will be, if the same differential equation, if we will be taking, let's say dx by dy, since here in the denominator part, no Murtaza, two two terms are there and we are not able to split them. I was telling you in one of the example that when we are having 5 plus 3 by 8, we can write it as a 5 by 8 plus 3 by 8, right?
Yes, ma'am.
But when we are having the same scenario like this, 8 by 5 plus 3, then we are not able to do anything. Yeah, here we can do the calculation, but now we are not able to do the calculation also, right?
Yes, ma'am.
We are not able to split also, we are not able to calculate also. So such scenario we have, can you see 8 by 5y plus 3x, something, a single term in the numerator and two terms in the denominator. So maybe if we will take the reciprocal, it will help. If we will take the reciprocal of this one, that is x plus 2y square by y, it will help. But since we are taking the reciprocal on this side, we must take the reciprocal on the other side. Otherwise, the complete concept will be invalid. Okay. So now
Okay.
we are getting x by y. Still, we are checking the possibilities. We are getting x by y and we are getting 2y square by y. Okay, now we are able to split. Now we will check that, okay, dy dx we are not able to make. What if the same linear differential equation we
Oh,
can
we
convert
can.
in this?
Yes,
Yeah,
ma'am. Dx by dy.
dx by dy plus px is equals to
Px is
q.
equal to q. So if
Okay,
will be e raised to integral p dy.
exactly. E raised to p dy will be if. And let's check. It seems like we are almost there. Let's check, are we able to arrange it like this, the other form, that is dx dy? Let's check it. So dx dy we are having, dx dy we are having on the other side. Okay, now px we are trying to make. So this x by y we can take to this side. Yes, right? Yes or no, with minus sign?
Yes, ma'am.
Does it looks like px? Can you tell me what is p, Murtaza?
X. No, no.
Hmm, what is p?
Now p is x by y.
I am arranging it for your clarity. I am arranging it since the side change. I always do side change like this, but don't get confused. Actually, why I do like this? Because this is dx dy is already positive over here, right?
Yes, ma'am.
That's why I take the other terms on this side. Okay. So while doing the calculation, I most of the time, I don't know you have noticed or not, in with other classes also, I take like this. If I need any term positive, and if that is already positive on the other side, then I try shifting the other terms on the other side. Okay, while dealing with quadratic equation also. So this is what we are having, which we can write as a dx dy minus x by y is equals to 2y square by y. Only side change I have. The right hand side completely I have written to left side, and left hand side completely I have written to right side. We are not transposing. We have not changed the equation. Getting it?
Yes, ma'am.
Okay. Now this looks like dx by dy plus px is equals to q, right? What
Yes,
is
ma'am.
p? What is p?
X by Y. No.
No.
1 by. Oh, yeah. Yes, ma'am.
Can you see it?
Yes, ma'am.
You got your p. Now integrating factor will be, so just do it from the very beginning. Note it down. Y dx minus x plus 2y square dy is equals to 0. Noted?
E raised to log Y.
Yeah. E raised to the power log by
Minus log
minus,
Y.
and this minus sign what we will do? What we will
Property of
do?
log. So we just get minus Y.
We just
Get minus Y.
m log n means log n to the power m.
Y to the power minus 1.
Exactly. And this e log e will get just neutralize each other. We will end up having y to the power minus 1 or 1 by as an integer. Have you noted the step? Or
Yes, ma'am.
okay, so now find the solution. Multiply with integrating factor, make the pattern. Now this time the pattern will be x into integrating factor is equals to q into integrating factor plus c. This time this will be the pattern. Instead of y, we will be having x this time. Getting it?
Yes, ma'am.
Give me a moment. My laptop is running out of battery. Solve it. Yes, Murtaza, are you able to do it?
Ma'am, I got 2x as
You
the final
got
answer.
to it. Okay, 1 by y was the integrating factor, right?
Yes, ma'am.
And what was q?
Q was 2y.
Is it x equals to 2y squared plus cy? Is it so? Is it so, Murtaza?
Yes, ma'am.
Have you got the same?
I didn't do the last step.
No, it will be 2y. And then I told you, no, when we were having y, that we have to keep only y on one side, that will reflect the solution.
Yes, ma'am.
Okay, so let's solve the question now. You have understood the concept. Let's start solving the question from the exercise. Solve it. Integrating factor is,
P is 2,
let me know. E to the power p
Q is sin
d.
x, E,
Yeah, to the power 2 dx, right?
yes, ma'am.
This is
E
what
to the
we are
power
going to.
2x.
Tell me the solution directly. Tell me the step.
Dy by dx into, x, y into e to the power 2x
Hmm?
is equal to integral of sin x into e to the power 2x plus c.
Okay, still we have to do this part, which you already know how to do it, right? By parts.
Yes, ma'am.
Let's do the next. Have you done any time everything of this by part all by yourself?
Yes, ma'am.
Because whenever we have done over here, I like together we have done. Independently, have you done, Murtaza?
Yes, ma'am.
Okay. Then let's do the next one. Because even if we have done it together, you have seen, you know, but if you have not done independently, there is a chance that you will get stuck. Okay, that's
Okay.
how the subject mathematics is. It will, like, you will feel like you know, but then you will get stuck if you have not done with, like, on copy with pen independently. If you have not done all by yourself, then there is a chance that it will create confusion. So integrating factor over here is
3. 3 dx, 3x. Y into 3x is
3.
equal to e to the power minus 2x into e to the power 3x.
E to the power 3x into e to the power minus 2x will be what? Just a second. Yes, e to the power 3x into e to the power minus 2x will be what, Murtaza?
We do integration by parts.
Integration by parts, this is very simple. Tell me.
We just multiply the. I don't know. We just add the exponents.
Exactly. Because we know that a to the power m into a to the power m is a to the power m plus n.
Yes, ma'am.
Okay. So into is there, so we will add them. Even if negative power is there, we will add them. And add them means obviously it will come out as a subtraction. So that
3
we
minus
will
2.
be able to do. Yeah,
E to the
3x
power x.
minus 2. See, this is very simple. You could have started doing the by part, but this is very simple. Can you see?
Yes, ma'am.
Okay, I'm leaving it. Any confusion, Murtaza?
No, ma'am.
Let's do the next one. What is the integrating factor?
P is equal to 1 by x.
Hmm.
Q is equal to x square.
Mhm.
So integrating factor is 1 by x dx,
Hmm.
which is log x.
Which will be
Uh, log x. So it will be only x.
it will be one. And now you will be able to do, right?
Yes, ma'am.
Because it after this it is very simple. You can check it. Y into x is equals to x square into integrating factor dx. Can you see the integration is simple?
Yes, ma'am.
Let's do the next. Dy dx plus sec x into y is equals to tan x. Integrating factor
Uh, minus cos x. E raised to minus cos x. Sec x dx.
is it so? Is it so?
Yes, ma'am. Integration of no. It's sec x. It'll be 1 minus tan x.
We cannot write because sec square x minus tan square x formula is there. Only sec x, there is a direct formula for integration. Have you learned it? The integration of only tan x, integration of only sec x, integration of only cosec x, integration of just cot x.
Yes, ma'am.
Let me, do you know the formula? Let me write it over. Just a second.
Sec x can also be 1 by cos x.
It will be log of sec x and tan x will also be there. Integration of, note the formulas now. Log of sec x plus tan x. Integration of tan x is what? Murtaza? Log of sec x, right?
Yes. Or we can write 1 by cos x.
Hmm. Integration of cot x is
cot x plus cosec x, log of cot x plus cosec x.
just a second. It is log of sin x plus c. Okay, I can show you how exactly we got this one. When you will be taking cot as a cos by sine, and when you will be taking the denominator one as a substitution, you will get the numerator one. But that will take time. Okay, when we will do like that, it will take time. Now only I am showing you just for the cot x, and the remaining you should learn. And the next one is integration of cosec x. Learn all the integration, because who knows, any
Integration
question
of
will come
cosec
directly.
x. Yes, ma'am. Log
Cosec x,
cosec x plus cot x
cosec minus
minus
cot
cot
x.
x.
Yeah, this is what we are having the integrations. Okay, so if
Ma'am,
directly you are,
will they ask us to solve it, or can we just write the formula?
the formula, where to use it, in such scenario to use it, can you
So do we
see?
have to solve the whole integration, like show them, or
If
can I
you
just
have
write it?
to show them, then you can show them also. Then you can show them also. Let me help you with cot x. Similarly, you can do the tan also. Cot means cos by sine, right? If such
Yes, ma'am.
integration will come, then so good. Such as like simple question it is. In from integration part, the method of substitution only. When we will be taking the denominator as a substitution, we will be getting the numerator, right? Sin x, it will be cos x dx is equals to du, right?
Yes, ma'am.
Right, Murtaza? So now we will be able to write that cos x dx du by only u log u plus c. U is sin x. So log of sin x. See, if this question will come, then great. You will be able to do it, right?
Yes, ma'am.
And even if instead of this one tan will come, then also you will be able to do it, right?
Yes, ma'am.
And what about this cosec and sec? So let's see, maybe sec, how we are getting cosec sec x as, integration as a sec x plus tan x. So here, even if we will write it as a 1 by cos x, what shall we take as a substitution? That is not making sense over here. So what can we do over here? We can do one thing. We can apply the method by parts. Okay. So if we will take trial and error method, we are trying to take. If we will take 1 and then sec x, will it make sense? Let's check it. First function, first function is x. First function we are taking 1. Okay, so first function integration of second function. Yeah, or if sec x we will be taking as a first function, that will be taking as a second function. Is it making sense? Check it. First function integration of second minus derivative of sec x. What is the derivative of sec x, Murtaza? Derivative of sec x is sec x tan x. Is it so?
Yes, ma'am. Second.
And integration of the second. That is only dx. Okay. So x sec x. But we ended up getting this part. And this one still we are not sure how to do. Let's check one more time. Is it possible? So here x sec x tan x we are having. If you will be taking this one as a first
Ma'am,
function,
sec
this one
tan x integral is just second. Oh, it has into.
into, okay, x is there. We could have taken, if sec x tan x will be there, that's just sec x we could have taken. But now we are not able. Let me see which possibility will work over here.
We split
So,
them by parts.
yeah, by parts. If this will be taking first function, this will be taking second function. So first function integration of second, which we will be getting sec x only. And then second function, the derivative of first and integration of second. So okay, we ended up getting the same integral which is there on the other side. Okay, this is not working at all. If we will be taking cos x as a u, then derivative will be minus sin x dx is equals to du, right? If we
Yes,
will
ma'am.
apply the previous logic, then it will become what? If we could have taken that one as a, let's check the last possibility also then. We have taken sec only as a first, no? This time we can take this one as a first function and this one as a second. First function, which we don't know, minus, no, it is not working. If we will take the help of triangle, the right angle triangle, cos x is u, not right angle triangle, cos x is u, then sin x will be cos x is u. If
Du.
someone in class 10, if someone will ask us if by using the previous knowledge, cos x is u, then find sin x. Then we can say cos square x is u square, right? And
Yes.
sin x we are not able to find, but sin square x we can say it is 1 minus cos square x, right? Sin x will be under root 1 minus cos square. This much we can say. Let me check whether that is working or not.
Ma'am, that is similar to
Similar to
the differentiation of sine inverse x.
here when we are trying to do the integration of sec x, no, pi parts must work over here. You can see it's not working. What is coming over there? Formula log of sec x plus tan x.
Ma'am, we can do
This root method will work over here. See, for under root 1 minus u square we got no. At the place of sin x, we will be writing under root 1 minus u square. And this we can substitute to the other side. Dx is equals to du. It will be du by under root 1 minus u square. Okay, minus sign will also come. Can you see from here how we came over here? what is the integration of square root of a square minus x square? It is, what is the integration of this one, Murtaza?
Uh,
dx
that's the
by
denominator.
under root x square, dx by under root x square minus a square. Is it sine inverse?
Yes, ma'am. It is sine inverse, but du is minus. It's negative.
So we can keep minus out. We don't have to worry about that.
Okay,
We
so
can keep that
it's sine
minus
inverse.
out. Let me confirm, is it sine inverse itself?
It is either sine inverse or cos.
Just a second. It is log of something. Just let me confirm first. Have you noted down the formula, Murtaza? All the formula
Yes,
in
ma'am.
one place?
Yes, ma'am.
Uh, so this formula is there or not?
Uh, it's there, but the solution is not.
I'm not talking about the solution. Just let me
Yes,
know
ma'am.
this formula is there or not. Not just a square minus x square. I'm saying under 1 by under root a square minus x square.
It's
Because
sine inverse x by a plus c.
have you checked?
Yes, ma'am. 1 by under root a square minus x square is sine inverse x by a plus c.
Okay. There must be any trick which will work over here. For sec x, we must get this.
We can write du by 1 square minus u square.
Yeah, we can write. And sine inverse will come. But the formula is basically the formula for integration of sec x is log of sec x plus tan x. And we are trying to prove the formula. Integration of sec x dx formula is log of sec x plus tan x. And if we are taking by parts, it is not working. If we are trying to take it in the terms of cos, it is not working. So we are trying to use any concept. If we will take the sec x, okay, let me multiply sec x plus tan x along with it so that I can take the denominator as a substitution, and then log will definitely come. But will it help? Because if we are multiplying the same thing in the numerator and denominator, it 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 is okay. Okay, we are not doing any drastic change, right? Let me check whether it will work or not. Sec
Yes,
into sec,
ma'am.
it will
This
sec
will work.
square x, and sec into tan, it will sec x tan x, and in the denominator we will be having sec x plus tan x. If we will take the denominator as a substitution, let's check, are we going to get the numerator? That way directly we will get log. So sec x, that is equals to derivative of sec x is sec x tan x, and derivative of tan x is sec square x. Oh yeah, can you see we got it?
Yes, ma'am.
Can you see? So this trick we have to apply over here. When we are going to
So the
do the
same thing goes.
integration, same thing goes for cosec. Okay,
Yes, ma'am.
nothing was working over here. We tried by parts. We tried by doing the substitution 1 by cosec. It was not working at all. And then we ended up getting it like this. Okay, we will do one, we will apply one trick, and that will make it so simple, which was eventually not that easy, right?
Yes, ma'am.
So if this I'm telling you to memorize the formula as it is, because every time here and there while solving the differential equation, while doing the integration, you will be getting this integration, this integration, this, or maybe this, where you can apply the formula as it is. But what if they will ask you to find the integration of seconds? Then this is how you will do it. Okay.
Okay, ma'am.
But the chances are you don't have to